fellow learners. In the series of applied chemistry, the topic we are taking today is soaps and detergents. When we go to the market, I think the soap is available at almost every retail store, and many of the Indians and multinational companies are involved in the manufacture of soap. Various types of soaps and detergents are available in the market, may it be toilet soap, hygiene soap, luxury soap, deodorant soaps, baby soaps, shaving cream soaps, and of course some synthetic detergents are also available in the market. When we do a cleaning of a soiled surface or a dirty cloth, the simple process is actually a very complex and consists of many physical and chemical steps like wetting of the surface, absorption of a layer of the soap or detergent at the interface between the water and the surface to be washed, and also between the water and the dirt. Dispersion of soil from the fiber or other material into the wash water, then preventing the soil or the dirt from being redeposited on the surface cleaned, and if detected oil droplets and dirt particles did not become suspended in the detergent solution in a stable and highly dispersed condition, they would coalesce together to form aggregates large enough to be redeposited on the cleansed surface. So the process, which appears to be very simple, that we rub the soap or we put the soiled cloth in the detergent solution and then rinse it with water, is actually involving a number of physical and chemical steps. The subtopics we are taking today are soaps, cleansing action of soap, difference between soaps and detergents, detergents and their history, then surface active agents like ABS, LAS, LABS, then principle of synthetic detergents. We will also discuss types of detergents, general considerations in soap making, then steps involved in preparation of soaps, different types of soaps available in the market and their properties, detergent binders and builders. Taking them one by one, let us introduce soaps. The soap, sodium and potassium salts of higher fatty acids such as oleic, stearic, lauric, palmitic acids are called soaps. Sodium salts are called as hard soaps and potassium salts are called soft soaps. A hard soap is moderately soluble in water and does not lather easily, rather that means does not give foam easily. Soft soap is fast dissolving and lathers readily and easily. It also performs better than hard soap as far as the cleansing action is concerned. Tallow, animal fats and coconut oil are the main source of the hard soaps, while linseed oil, castor oil, etc. produce soft soap. Mahua and groundnut oil produce soaps of intermediate consistency. The soaps are soluble in water and the solution has excellent lathering and cleansing properties. The basic principle of making all kinds of soap such as toilet, laundry, household, medicinal, marine and industrial soaps is same, that is combination of higher fatty acids with sodium or potassium hydroxide. Shaving creams, liquid soaps are well-known examples of soft soaps, while other types given above or talked above are examples of hard soaps. In modern technology, oil or fat is first hydrolyzed into glycerol and fatty acids, which are then neutralized by adding alkali to form soap. This procedure is quicker, better controlled and makes the recovery of the byproduct glycerol easier. The oils used for the manufacture of soap are usually coconut oil, cottonseed oil, corn oil, palm oil, olive oil and castor oil. The fats used are tallow, lard and grease. Unsaturated fatty acids make soft soaps which turn rancid in light and moist air. We have used the term fatty acids again and again. Fatty acids are aliphatic monocarboxylic acid mostly obtained from the hydrolysis of natural fats and oils. They have the general formula RCH2NCOOH and mostly have straight chain, where N is a large number so that it becomes a fatty acid. The another term which will be used is saponification value. It indicates the average molecular weight of a fat or oil. The saponification value may be defined as the number of milligrams of KOH needed to neutralize the fatty acids obtained by complete hydrolysis of 1 gram of an oil sample. Thus, saponification value gives us the information whether an oil or fat contains high proportion of lower or higher fatty acids. In practice, a known amount of oil or fat is refluxed with excess amount of standard alcoholic potash solution, and the unused alkali is treated against a standard acid, and in this way soap is produced and glycerol is the byproduct. Since butter has a large proportion of lower fatty acids than lard and tallow, the former has high saponification value. Coconut oil has a comparatively higher saponification value as compared to olive oil and castor oil. Good soaps are obtained from palmitic and stearic acid, but the resulting soaps are sparingly soluble in cold water. They are thus blended with C12 to C14 fatty acids, as their sodium salts are more soluble in water. Thus, the soap obtained from a mixture of coconut oil and tallow or coconut oil and cottonseed oil is a better soap than soap obtained from the pure oil. Similarly, soap obtained from stearic acid dissolves too slowly in water, but the soap made from coconut oil dissolves too fast. So, a mixture of the two has a right solubility. Tallow, which is very rich in stearin, is the main fatty material used in the manufacture of soap. It is low melting 45 to 50 degrees centigrade animal fat and is obtained by digesting solid animal fat with steam. The grade of tallow to be used depends upon the quality of soap to be manufactured. Soaps made of tallow alone are too hard and too insoluble in water, and hence it is always mixed with some other oil like coconut oil. Hydrogenated oils, palm oil, cottonseed oil and soybean oils also form the stock mixture in varying proportion for soap making. Greases are the other important material used in soap making. They are animal fats and obtained from hogs and smaller domestic animals. They are either refined by solvent extraction or by steam rendering. Alkaline liquors called foods obtained in the refining of oils are also used in the manufacture of soaps. Coconut oil soap is the best for ready lathering even in salt water, but its large bubbles burst quickly. Coconut oil is used in the manufacture of marine soap. Now, stearic acid soaps form much smaller bubbles lasting longer and used in making shaving soaps. Palm oil is used for making toilet soaps and castor oil is used for making transparent soaps. Let us now discuss the cleansing action of soap. It depends on its physical properties as well as on its chemical properties. There are several factors such as adsorption, surface tension, electrostatic forces of the polar soap molecules, its wetting action, emulsifying power, etc., which are of great importance in deciding the cleansing action of soap. Soap lowers the surface tension of water, and this property of soap is very important in its cleaning power because that enables the water to wet and so to come into close contact of even a greasy surface. Thus, soap wets the surface of a fabric due to decrease in surface tension of water. Also, lowering in surface tension can be easily effected by dissolving soap in water. Soap solutions also have another important property of emulsifying oils and fats. Hence, they emulsify grease, oil, etc. that hold the dust particles. Soap forms a protective film on the surface of a fabric and makes it difficult for grease and the dirt particles to come together again. The dust and grease particles can then be easily removed by shaking vigorously with water. Soap is a kind of molecule in which both the ends have different properties. One end is the hydrophilic end and the other end is known as hydrophobic end. Water loving and water hating, hydrophilic and hydrophobic. The first one is the hydrophilic end, which dissolves in water and is attracted to it. The second one is the hydrophobic end, that is dissolved in hydrocarbons and is water repulsive in nature. If on the surface of water soap is present, then the hydrophobic tail, which is not soluble in water, will align along the water surface. Here comes the concept of micelle. In water, the soap molecule is uniquely oriented, which helps to keep the hydrocarbon part outside the water. When the clusters of molecules are formed, then hydrophobic tail comes at the interior of the cluster and the ionic end comes at the surface of the cluster, and this formation is called as a micelle, which is shown here in this diagram. When the soap is in the form of micelles, then it has the ability to clean the oily dirt which gets accumulated at the center. These micelles remain as colloidal solutions. Therefore, the dirt from the cloth is easily washed away. The soap solution appears cloudy as it forms a colloidal solution which scatters light. Now let us talk about detergents. Detergents are amphipathic compounds with charged hydrophilic or polar compounds at the end of the lengthy lipophilic hydrocarbon groups. The lengthy lipophilic hydrocarbon group is the tail, whereas the charged hydrophilic group is the head. They are commonly called as surfactants, which have the capacity to lower water's surface tensions. Since it comprises of one or more surfactants, a detergent is a powerful cleaning agent. Let us talk about the difference between soaps and detergents. Soaps are the sodium salt of long chain fatty acids, whereas detergent are the sodium salts of sulfonic acids. The ionic part of the soap is COONA, whereas that of detergent is SO3Na. Soaps are prepared from animal fats or vegetable oils, whereas detergents are prepared from hydrocarbons obtained from crude oil. Soap's effectiveness could be reduced when used in hard water, whereas detergents are effective even in hard water. Soap form a scum in hard water, whereas detergents do not form scum in hard water. Soaps have poor foaming capacity in hard water, whereas detergents have rich foaming capacity. Soaps are biodegradable, whereas most of the detergents are non-biodegradable. Let us discuss the history of detergents. We know that soap lowers the surface tension of water, and this property of soap is an important factor in its cleansing action. There is another property of soap solution which plays most important part in the cleansing action. This property is of emulsifying oils and fats. In the light of two important properties, attempts were made in Germany and other countries owing to a shortage of fats during World War I to produce substances called detergents, very different in chemical nature from an ordinary soap or salt of a fatty acid. For example, some acids were first prepared by the action of sulfuric acid on higher unsaturated hydrocarbons containing about 10 to 18 carbon atoms. The sodium salt of these acids were found to reduce the surface tension of water and to have valuable wetting and detergent properties. Now, surface active substances. Substances which lowers the surface tension of water are commonly known as surface active substances. They have the property of altering the conditions at interfaces. These, when dissolved in water or dispersed in a liquid, wash a surface clean by removing oil in which dust particles are dispersed. A detergent may be regarded as a chemical formation which essentially consists of surface active agents or surfactants and subsidiary constituents such as fillers, builders, boosters, etc. The detergent may be in the form of solid liquid, paste or even a powder. The modern concept of surface active agents or surfactants includes soaps, detergents, emulsifiers, wetting agents and penetrants. Surfactants have ability to modify the surface properties of liquids in which they are dissolved. The modern theory of the action of surface active agents relates to the process of adsorption. The inherent property of surface active agents to adsorb at interface results from their molecular structure. They have essentially two parts of a molecule, a hydrocarbon chain and a polar group. The hydrocarbon chain consists of 12 to 18 carbon atoms and the polar group may be carboxylate, sulfate or sulfonate, etc. If the hydrocarbon chain is smaller than 12 to 18, the compound is expected to be lacking in surface activity, while if the carbon chain is too long, it will result in the surface active agent having a limited solubility in water. So, the hydrocarbon chain has an affinity for fatty acid, greases and similar long chain compound, whereas the attached polar group will have an attraction for water or aqueous solution. If solvent is water, the hydrocarbon chain may be regarded as the hydrophobic group and the polar group as the hydrophilic group. The hydrophobic group may be of complex nature and may contain both straight chain and ring compounds. Soaps are an important class of surface active agents. They can be represented as RCOOX, where R is the hydrophobic group, X is usually an alkali metal. For example, sodium laurate. Soaps ionize in water to some extent like this, and we are getting two ions, one anion and one cation. The active hydrophilic group in its anion COO- and so soaps are classified as anionic surfactants. For a long time, soaps were the only known surfactants and they were not only efficient but inexpensive too. Sodium and potassium soaps used in proper conditions are probably the best available detergents and wetting agents. However, they have two serious disadvantages. They form insoluble calcium and magnesium salts. This condition is particularly troublesome for washing processes in areas where water is hard. Secondly, soaps are inactivated in acid conditions in which hydrolysis takes place to give back undissociated acids. Also, soap molecules react with the salts of calcium and magnesium and form a precipitate. This precipitate begins floating as an off-white kind of a layer over the water. This layer is known as scum. Soaps lose their cleansing property in hard water because of the formation of this scum. Alkyl benzene sulfonate is a class of anionic surfactants consisting of hydrophilic sulfonate head group and a hydrophobic alkyl benzene tail group. They are most widely used in synthetic detergents and may be found in numerous personal care products and household care products like laundry detergent, dishwashing liquid, etc. Alkyl benzene sulfonate were first introduced in 1930s in the formation of branched alkyl benzene sulfonate BAS. However, following the environmental concerns, these were replaced with linear alkyl benzene sulfonate LAS during the 1960s. LAS is an anionic surfactant which is widely used in detergents and cleaners both in industrial and household application. This term is applied to a family of straight chain chemical compounds sometimes called as soft detergent. It makes the molecule more biodegradable as compared to BAS. It was introduced in 1964 as the readily biodegradable replacement for highly branched ABS. LAS is found in wastewater. It is claimed that it acts as a corrosion inhibitor for stainless steel and aluminium. Linear alkyl sulfonate is also known as linear alkyl benzene sulfonate LABS. These are the structures for ABS and LABS. Synthetic detergents were used in order to remove these deficiencies of soaps. We had to search for other surface active agents so that they can perform efficiently in hard water. As I discussed earlier, it was researched in Germany in the year around 1930. These new phase active reagents were found to be similar in detergency, wetting and foaming properties to soaps, but calcium and magnesium salts were now found to be soluble in water. The substitution of the sulfate group or the sulfonate group in place of COOH group of soap gave products of greater water solubility. This discovery gave impetus to the search for their surface active agents and to the development of the synthetic detergent industry. Synthetic detergent as well as wetting agents of varied chemical nature and with properties which make them specially suitable for specific purposes are now being manufactured. They find extensive use not only as detergent substitutes for soaps but also as wetting agents in dyeing to increase the effectiveness of insecticide spray and for many other purposes. In general, synthetic detergent is used to indicate a synthetic material which is used for cleaning and usually does not include soap. The cleansing action of surfactants depends upon the property of decreasing surface tension or interfacial tension at boundary surface between two phases of matter. So with this we come to end of the first part of soaps and detergents in which we discussed and compared soaps and detergents. Thank you.